Hi, how are you today? These notes are about parabolas. These notes are going to go through a couple of examples. You might have seen similar examples in the classwork, but these notes are kind of just a supplement to that. So I'm going to assume some, prior knowledge about parabolas while we go through these. What I have restated up in red is the definition of a parabola. We're talking about the set of points equidistant from a given point and line called the focus and the directrix. And we've kind of labeled this distance from the vertex of our parabola to the focus. We're labeling that as C. We know that, let's say our vertex was at 0, 0. If I had a focus maybe right here, then our directrix maybe here, oh, that was weird, then our parabola would end up kind of opening up like this. Let me maybe try to make that a little bit better. We know that we have our vertex at 0, 0, and we're kind of coming around and hugging the focus. And I know I didn't do a great job with that picture, but any point along this parabola is equidistant to the focus and the directrix. And of course we measure distance from a point to a line as a perpendicular. One thing that might be a little bit different is we are not sticking with parabolas with only vertical axes of symmetry anymore. We have also seen examples where perhaps we have a vertical directrix, and maybe if our focus was over here, then our parabola would possibly open this way. So notice we're not dealing strictly with functions. We just have these relations, and notice that if it's a sideways parabola, then it fails the vertical line test. So don't forget about these other kind of orientations we can have. Let's just investigate what an equation might be. Let's just say both of these vertices for both of these parabolas was at 0, 0. This first equation could be represented as y equals 1 over 4c x squared, not shifted at all. Notice 1 over 4c is taking the place of what we used to call our a value, our lead coefficient. So that is an important fact that we should make sure we remember, that a is equal to 1 over 4c. C in this case, let's see if I can switch colors here. C in this case is this distance, C. And of course it's the same from the vertex to the directrix, since every point on that parabola is equidistant. In the second example, here's our C value, here's our C value, and our equation that might represent that second relation is x equals 1 over 4c y squared. Notice these are actually our x's and y's have kind of switched spots here, but our a value is still telling us kind of essentially how wide the parabola is, so that really hasn't changed. So as long as we know that a equals 1 over 4c, if we have x equals something y squared, we're going to get the sideways parabola. Y equals something x squared, that's kind of old news, we're used to those. That's our vertical axis of symmetry parabola. Let's look at some examples. So this example says graph, find focus and directrix, and here we have our equation. The first thing we notice is that it is a positive a value, and we have x equals something times y squared. So I know that the first thing I want to kind of note to myself is this is going to open to the right. It's going to look something like this. I know it's going to be a sideways parabola, and I know it's positive. That tells me it opens to the right. If we had a negative a value, that would open to the left. One thing we can tell from this equation is the shift, but we have to be careful. Since now x and y's have sort of switched spots, our vertex here is not -2, -3, like you might think. Because it's our sideways parabola, the way that I always think about equations is I'd like to know some points that make this equation true. So in this equation, I can see that if y was -2, then x would end up being -3. If y was -2, then x would end up being -3. Can you kind of imagine that if you plug in -2 for y, we get 0 times times 1/16, and then x is just equal to -3. So that's the point -3, -2. That is our vertex here. We have to be very careful when things are when the x's and y's are switched. So there's our vertex. All right, and the next thing I'd like to figure out is our c value. But we know that a, in this case, is 1/16. Remember from the previous slide that A is equal to 1 over 4C. If I solve this for C equals 16, C is equal to 4. Remember what C stands for. C is the distance from the vertex to the focus. I know that this parabola opens to the right. So from the vertex, I'm going to move 4 units to the right. That brings me right here. And that's going to give me the focus. I can also move 4 units to the left, and that will bring me to where I know the directrix has to cross through. 1, 2, 3, 4. I knew that the directrix was to the left and the focus was to the right because of the direction that this parabola has to open. So that's coming from some familiarity. At this point, I can sketch in my parabola. I'm not gonna be super accurate with this, but in terms of just kind of a rough sketch, something like this. I know that I could plug points in if I wanted, but I found my focus and I found my directrix. Let me just write out the point so I can actually answer the question. The focus ended up at the point 1, -2, and the directrix is the line x equals -7. I really got that just by counting, looking at the axes, and then just marking off where they ended up. Let's do one last example. What if we're given information about the parabola, and I need to come up with the equation? So this says write the equation of a parabola whose focus is 1, -8, and whose directrix is y equals 2. The first thing I'm going to do here is sketch a graph. I know that if I know the focus and I know the directrix, I can definitely find the vertex because it's halfway in between. The other thing I know from this given information that since our directrix is horizontal at y equals 2, we must have a either opening up or opening down parabola. I know that it's going to look like y equals something x squared in this case. Let me plot the focus, 1, -8. So here's our focus. Can you kind of imagine where the parabola is going to fall? I know the vertex will be halfway between this, so I'm going to have to figure that out. We should label this up here as 2. I guess my picture is not quite to scale, but I think that's okay. I can just kind of imagine that wherever the vertex is, our parabola is going to open down. Think of the behavior of the parabola. It's always kind of hugging the focus. So I know that it'll look something like that. Now let's try to find where the vertex is. I want to first calculate the distance between the focus and the directrix. I can cut that in half, and there's my C value. -8 up to 2 is a distance of 10. So I know the C value is going to be 5. So let me count 5 units down from our directrix, or 5 units up from our focus, and we will find our vertex. So let's see, 1, 2, 3, 4, 5. There we go. And that is at -3 here. I know this x-coordinate was 1 because it has to lie on that same vertical line that I drew in brown. So I knew that our C value was 5. All right, so if our C value is 5 and A is equal to 1 over 4C, then A is equal to 1/20. The last thing I have to do is write the equation applying the shift. So our vertex, I know the vertex is at 1, -3 from what we kind of discovered already. I know it opens down, and I know the A value. So I can write this in vertex form. Y equals 1/20, which isn't right yet, because I know that that parabola has to open down. So it's up to me to remember to throw in that negative sign. The C value is a distance, so I can't just blindly say 1/20 because it's not telling us which direction it's opening in. C is just a +5 because it's representing a distance from the vertex to the focus. I have to know just by my sketch that it has to be negative. Let's continue. It was shifted 1 unit to the right and 3 units down. I'm really using vertex form here. Our vertex was at 1, -3. So here is our equation. Remember, if you know C, you know A. If you know A, you know C. You can always find them. The other difficult parts with parabola questions are knowing the direction in which they open, maybe finding the vertex, maybe plotting, the focus and the directrix. And I think sometimes we even have to complete the square before we can see anything, maybe from a graphing example. We didn't have to do that here, but that's another thing you want to make sure you know how to do. Good luck with the parabola problems.